Okay, so this week we talked about our skeletal system. Of course, the skeletal system is there to protect, to support our body and the weight, to allow for movement, have something for muscles to attach, and to protect our organs. So just some different parts here. We, of course, have our cranium, our head, mandible, jaw, ribs. I think everyone knows your sternum there in the middle, vertebrae lining your back for support, your pelvis, femur, patella, tibula, and fibula are all in your legs. Your clavicle and scapula, your humerus, radius, and ulna there in your arms again. You also have your carpals at the base of your hand, metacarpals there in the middle, and the very tips are your phalanges. Kind of the same thing at the bottom. You have your tarsals in the middle, metatarsals, or tarsals at the base, metatarsals in the middle, and your phalanges are the very tips of your toes. Just kind of pointing out a couple of special bones. Your cranium, of course, is a very important bone. It's actually separated when you're young and fuses together as you grow. And it allows a cavity for your brain and helps protect your brain and give you the facial skeleton that you need. Your vertebrae, of course, play another very important part. They allow support for the weight for your body. It also protects your spinal cord and allows for your spinal cord to attach to it. And then the next thing I like is, of course, your phalanges and your toes. Your toes support you for balance, running, walking, all that type of stuff. So moving on, we do have different sizes and shapes of bones. We, of course, have the long bone, which is long and would be like your humerus. You have your flat bone like your sternum. Short bones would be like your carpals. And then you have irregular bone shapes, which are like your vertebrae. Another thing our body does is ossification. And it usually begins in about the 3rd month of a fetus's life. So at first there's intramembranous ossification and then endochondral ossification, and then after you're born there's a secondary ossification until you're about 18 to 25, and that's when it finishes, and that's when most of your cartilage has been replaced by bone, or all your bones have been fused together, say in your hands and in your skull and everything like that. And then that takes us on to our vertebrae. So here's my rough drawing of your vertebrae. Of course, the very top is your cervical. Going into kind of your rib area would be your thoracic. The bottom underneath your ribs would be the lumbar. You have the sacrum and the coccyx. Cervical would have 7 vertebrae in it, thoracic 12, lumbar 5, sacrum is 5 that are fused together, and the coccyx has 4 that are fused together. Okay, and then moving on, so in our bones, say if we're looking at a dissected piece of our arm, you would see that there's both compact bone and spongy bone. The spongy bone is loosely packed. It's very light, made of the trabecula cells. It also has red bone marrow, which helps create blood. And then the compact bone is a lot more dense. It's heavier, sturdier, provides more protection. It's made of the osteons, and it has yellow bone marrow, which helps store fat. When your bones are growing and remodeling over time, there are many different things that factor into that, such as hormones and drugs. And then finally, the last thing we wanted to talk about was why your bones pop when you pop your joints. So there's synovial fluid in your joints there, filling the space, and whenever you're popping them, you're stretching them, and there's gases such as nitrogen and oxygen in them that try to escape and form bubbles, and that is actually the popping sound you're hearing whenever you pop your joints. So that's just a little bit of things that we learned about the skeletal system this week.